In the past, computing systems were centralized. All the resources were in one place. This is no longer the case. Today we use distributed infrastructure. This means that resources are spread across multiple locations. These resources include hardware, software, and data. Distributed infrastructure is essential for modern computing. It offers advantages in performance, reliability, and scalability. Distributed infrastructure is different from traditional centralized systems. It is more complex but offers many benefits. This essay explores the characteristics, benefits, and challenges of distributed infrastructure. It also provides real-world examples and discusses future trends. This essay aims to explain distributed infrastructure in simple terms. It is suitable for readers with a basic understanding of computing concepts. By the end of this essay, readers will have a good grasp of this important topic. Distributed systems have several key characteristics. These characteristics set them apart from centralized systems. Understanding these characteristics is crucial for designing and managing distributed infrastructure. Firstly, distributed systems allow for resource sharing. Hardware, software, and data can be shared across different locations. This enables efficient utilization of resources. For example, a server in one location can be used by users in another location. Secondly, distributed systems enable simultaneous processing. Multiple machines can work on the same task at the same time. This improves performance and efficiency. For instance, a large dataset can be processed much faster by dividing it among multiple machines. Thirdly, distributed systems are scalable. The computing and processing capacity can be easily adjusted. Adding or removing machines allows for scaling up or down as needed. This flexibility is essential for handling varying workloads. Finally, distributed systems exhibit fault tolerance. If one machine fails, the system continues to function. Other machines take over the workload of the failed machine. This redundancy ensures high availability and reliability. Distributed infrastructure offers numerous benefits over traditional centralized systems. These benefits make it a preferred choice for many organizations. The improved performance, increased reliability, and enhanced scalability are key advantages. One significant benefit is improved performance. Distributing workloads across multiple machines reduces the load on any single machine. This results in faster processing times and reduced latency. Users experience quicker response times and smoother application performance. Another benefit is increased reliability. Distributed systems are designed for fault tolerance. If one component fails, the system continues to operate without interruption. This redundancy minimizes downtime and ensures business continuity. Enhanced scalability is a major advantage. Distributed systems can easily adapt to changing demands. Adding more resources to the system increases capacity. This scalability is crucial for businesses experiencing rapid growth. Furthermore, distributed infrastructure can be cost-effective. Organizations can leverage existing resources and avoid investing in expensive centralized hardware. Cloud computing, a form of distributed infrastructure, offers pay-as-you-go models, further reducing costs. Distributed systems are used in many applications today. Their ability to handle large-scale workloads and provide high availability makes them ideal for various scenarios. Cloud computing is a prime example. Cloud providers like Amazon Web Services, Microsoft Azure, and Google Cloud Platform rely heavily on distributed systems. These platforms offer a wide range of services, including storage, computing power, and databases, all built on distributed infrastructure. Content delivery networks, or CDNs, are another common use case. CDNs use a geographically distributed network of servers to deliver content to users from the closest server. This reduces latency and improves the user experience, especially for websites and applications with a global audience. High-performance computing, or HPC, relies heavily on distributed systems. HPC applications require massive computing power to solve complex scientific and engineering problems. By distributing the workload across a large number of interconnected computers, researchers can tackle problems that would be impossible to solve on a single machine. Distributed databases are essential for handling large datasets and ensuring high availability. These databases distribute data across multiple servers, improving performance and resilience. The Internet of Things, or IoT, generates vast amounts of data from interconnected devices. Distributed systems are crucial for processing and analyzing this data in real time, enabling applications like smart homes, industrial automation, and connected vehicles. Section 5. Challenges in distributed infrastructure. Despite the numerous benefits, distributed infrastructure presents challenges. These challenges arise from the complexity of managing resources and ensuring data consistency across multiple locations. One major challenge is complexity. Managing and maintaining distributed systems is inherently more complex than managing centralized systems. Administrators need to handle a larger number of components and deal with issues like data synchronization and network latency. Security is a critical concern in distributed systems. Protecting data and resources spread across multiple locations requires robust security measures. Access control, encryption, and intrusion detection systems are essential for securing distributed infrastructure. Network latency can impact the performance of distributed systems. Communication between components located in different geographical regions can introduce delays. Minimizing network latency is crucial for ensuring responsive applications and a seamless user experience. Data synchronization is another challenge. Maintaining data consistency across multiple locations can be complex. Different components of a distributed system need to access and update data in a coordinated manner to avoid inconsistencies. Section 6. Key components and technologies. Distributed infrastructure comprises several key components and technologies that work together to deliver its capabilities. Understanding these components is essential for designing and managing distributed systems. The network forms the backbone of any distributed system. It connects different locations and enables communication between components. The network infrastructure can range from local area networks within a data center to wide area networks spanning across continents. Servers are the workhorses of distributed systems. They host applications, store data, and process requests. Modern distributed systems often utilize virtualization technologies to create virtual servers, allowing for greater flexibility and resource utilization. Storage systems are crucial for storing and managing data in a distributed manner. Distributed file systems allow data to be accessed from multiple locations transparently. Object storage provides a scalable and durable way to store large amounts of unstructured data. Other essential components include load balancers, which distribute traffic across multiple servers to prevent overloading, and message brokers, which facilitate communication between different parts of a distributed system. Section 7. Core concepts in distributed systems. Distributed systems rely on fault tolerance, data consistency, security, and performance optimization. Fault tolerance ensures high availability through redundancy and failover mechanisms. Data consistency ensures all components have a consistent view of data. Security involves protecting data from unauthorized access. Performance optimization ensures responsive applications and seamless user experience. Section 8. Real-world examples of distributed systems. Many companies have successfully implemented distributed systems to achieve scalability, reliability, and performance. These real-world examples showcase the power and versatility of distributed infrastructure. Google is a prime example of a company that relies heavily on distributed systems. Its search engine, Gmail, Google Maps, and other services operate on a massive distributed infrastructure spanning multiple data centers worldwide. Google's distributed file system, GFS, and its distributed database, Spanner, are examples of technologies that enable its services to scale and perform reliably. Amazon Web Services, or AWS, is another prominent player in the distributed systems space. AWS offers a wide range of cloud computing services built on a distributed infrastructure. Amazon S3, its object storage service, and Amazon EC2, its elastic compute cloud, are used by countless businesses to build and deploy applications. Microsoft Azure is another major cloud provider that leverages distributed systems extensively. Azure services, including Azure Blob Storage, Azure Virtual Machines, and Azure Cosmos DB, rely on a distributed infrastructure to provide scalability, reliability, and performance. These examples demonstrate that distributed systems are not just theoretical concepts but are actively used by leading technology companies to power some of the world's most popular and critical applications. Section 9. Future trends in distributed computing. Distributed computing is evolving, driven by technological advancements and the demand for scalable, reliable systems. Edge computing reduces latency by bringing computation closer to the data source. Serverless computing abstracts infrastructure, letting developers focus on code. AI and ML optimize resource allocation and enhance security. The future of distributed computing is bright, with exciting developments ahead.